Good morning, class. We are looking at chapter 4, applications of derivatives, 4.4, optimization problem, part 2. Let us enclose a rectangular area of 288 square feet and then divide it into 3 equal size pens with parallel size. What dimensions will minimize the material needed? Well, this is given to us, otherwise we have to come up with that. Let's define our variables. X represents the width, Y represents the length. The objective is to minimize the material. We need 1, 2, 3, 4x, 1, 2y, and they add up to give us the maximum. So the objective is to minimize, my apologies, minimize the p equals 4x plus 2y. Subject to the area is supposed to be 288. So the constraint, the area, which is x times y, is 288. The objective function has 2 variables, x and y. So we solve for y in the constraint. We put it into the objective function to make it a function of 1 variable. So p now becomes p of x equals 4x plus 2 times 288 over x. The product of these two is 576 divided by x, or x to the power of minus 1. The reason we write it in this format to get it ready for differentiation. And x represents sides, dimensions must be positive. So x must be larger than 0. So to find critical points, we find p prime, which is 4. The product of these two is negative 576 x to the power minus 2. Because we are going to set this equal to 0, we are going to add them up in the following manner. We take this down, we make it 576 over x squared. We take a common denominator, which is x squared. We make this 4x squared over x squared, and we get 4x squared minus 576 over x squared. P prime equal to 0. A fraction is 0 when the numerator is 0. That means 4x squared equals 576. That means divide by 4, x squared becomes 144. That means there are 2 answers, plus minus 12. However, x must be positive. So we have an open interval with 1 critical point, x equals 12. By the way, p prime does not exist, makes the denominator 0, which is not part of the domain. So we have 1 critical point, we have an open interval. Is this going to maximize or minimize? Either way, it becomes absolute. But which one is it? We go with the second derivative test using this one. 4 gives you 0. The product of these two, negative 576 and negative 2, gives you positive 1152 x to the power of negative 3. The second derivative test, or 1152 over x cubed. The second derivative test says evaluate p double prime at the critical point to observe whether it's positive or negative. So you don't even have to know what the answer is to recognize this is positive. Positive means concave up. That means minimum because the shape is like that. So the minimum occurs when x is 12 feet. So what is y? Going back to this formula, y is 288 divided by x, or 12, becomes 24 feet. So x is 12 feet, y is 24 feet. What is the minimum amount? 4 times x, which is 12, plus 2 times y, which is 24. We need 96 feet. That would be the minimum amount of material. From a thin piece of cardboard, 8-inch by 8-inch square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? Drawing is a must. So we have an 8 by 8 cardboard. We're going to cut corners by X amount. So this is X, so is this one. This is X, so is this one. X, 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 X. Which means if we cut X from each side, this will be 8 minus 2X. This will be 8 minus 2X. When we fold it, will look like that. We want to maximize the volume. So the objective is the length times the width times the height is the volume. The constraint is what we just made up here. The width equals the length equals 8 minus 2X. The height is X. And now to make volume a function of one variable X, just replace L, W, and H accordingly. And the volume becomes 8X times 8 minus 2X squared. Now, we have to figure out what the value should be, the possible values of X. There are two easy ways to say it. One, if you look at this one, if you cut it in half, you get 4, and it has to be less than 4, because if you cut it precisely in half, you can't make up a box. There is no box. That's one way. The other one, if you set 8 minus 2X equal to 0, X becomes 4. So if X is 4, the volume is 0. You can't have any box. So X must be between 0 and 4. Why is it larger than 0? Because you're cutting something. Otherwise, you're not cutting anything. You're not creating a box. Ultimately, it becomes a dimension. So X is between 0 and 4. And that's important. Now, to work on this, first we're going to raise this to the power of 2. 8 squared is 64. 2 times the product of the two is minus 32x plus 4x squared. When we multiply by x, we get 64x here, minus 32x squared, plus 4x cubed, and we put it in the descending order, which means we put the 4x cubed first. I'm going to erase my work. So 4x cubed minus 32x squared plus 64x. Now we are ready to do calculus. We need the critical point or points. To do so, we have to find v prime. V prime is 12x squared minus 64x plus 64. V prime of x in essence, okay? And we can factor the common factor of 4 out. We get 3x squared minus 16x plus 16. To factor this, because 3 is a prime number, it's easy to see 3x and x. And then 16 is 1 times 16, 2 times 8, 4 times 4. They must have the same sign, both of them positive or negative, because this is positive. Negative will do the job. If you look at the middle term here, it's important to understand this. This is minus 4x. This is minus 12x. And they do add up to negative 16x. That's how you check it out. In any event, set each one equal to 0. So I'm going to erase my work again. This gives you x equals 4/3. This gives you x equals 4. There are two critical points. We go back to our interval in essence. X is between 0 and 4, and this is the interval form. So 4 is out. Now we have an open interval and one critical point. So local becomes absolute. Is this going to be absolute max or mean? We do one of the tests. In this case, we do the second derivative test, which is 24x. V double prime is 24x minus 64. And the second derivative test says evaluate this at the critical point to see whether you get positive or negative. We just want the sign. So 24 cancels out the 3, gives us 8 times 4, 32 minus 64. Negative 32. And please understand, we are interested in the sign. Negative means concave down, means maximum because of the shape. So x is 4/3. What is the width? What is the length? 8 minus 2 times that. And that is 16/3. Again, just a quick justification. This is 8/3, everybody. So instead of 8, I'm going to write 24/3. And I get 16/3. So the dimensions are 4/3 by 16/3 by 16/3. Again, what do we cut? We cut 4/3. What is the maximum volume? Let's multiply those numbers. We get 1024 over 27, or 37 and 25 over 27 cubic inches. This is elementary. Remember, these are the 2 steps of calculus. The rest are elementary algebra. A stereo manufacturer determines that in order to sell X units of new stereo, the price per unit in dollars must be P of X equals lowercase p of X equals 1000 minus X. The manufacturer also determines that the total cost of producing X units is given C of X equals 3000 plus 20X. Find the total revenue. Revenue by definition is the number of units times the price. So you multiply them out. So the product of these two gives us 1000x minus x squared. That is the revenue. Algebra. What is the total profit? By definition, revenue minus cost. So you're going to subtract the cost from the revenue. So 1000x minus x squared is the revenue, minus 3000 plus 20x is the cost. We are going to distribute the negative sign, minus 3000 minus 20x, and these two are like terms. We put them together in descending order, we get minus x squared plus 980x minus 3000. So far, we've done algebra only. How many units must the company produce and sell in order to maximize profit? Well, you're maximizing the P of X. So you are going to differentiate it into minus 2x plus 980. So P prime of X is minus 2x plus 980. To find the critical point, we set this equal to 0. X becomes 490. Is this going to maximize or minimize? We're going to do the second derivative test. By the way, X is the number of units that are produced and sold. So the domain should be 0 to infinity, an open interval. One might say, can it be 0? Yeah, it can, but in that case, we are not doing anything, okay? And of course, you have to put the 0 into the profit function, which gives you negative. So you could use bracket here, but it's really not necessary. With that being the case, P double prime is negative 2. We are interested in the sign. Negative means concave down. Maximum occurs at x equals 490 based on this. What is the maximum profit? Well, here's the profit function, everybody. plug in 490 minus 490 squared plus 980 times 490 minus 3000. Put it into a calculator, and the answer is $237,100. What price per unit must be charged in order to make this maximum profit? Well, this was the price function. Okay, so plug in 490 into the price function, and that gives us $510. So what price should we charge? $510 per unit to maximize profit.